Good morning, everyone. This is Mrs. Moody coming straight from my dining room, and this is my assistant,
Mrs. Ruthie.
Mrs. Ruthie, and who do you have?
Mrs. Chloe.
Mrs. Chloe. So in 5th grade, we have to plan and carry out investigations of physical changes, and we also have to plan and carry out investigations to determine whether a chemical change has occurred. And the way that you can, some of the ways that you can determine a chemical change is through a production of, excuse the dogs growling in the background, sorry. You have to, there will be a release of gas, a production of gas, first of all. There could be an odor change, stinky, stinky, stinky. Or it could be a color change, or it could be a new substance is formed. Do you know what a substance is? It's a fancy word for new stuff. Okay? So we have 3 little things set up to determine whether these are chemical or physical changes. And I think you might be a little bit surprised. So our first one we have is our handy dandy, everyone always does it, chemical change between acetic acid diluted and sodium bicarbonate. Now it's in a balloon because I've pre-done the balloons just to make it a little bit faster. So anyway, acetic acid is a fancy word for vinegar. And in here we have sodium bicarbonate, also known as baking soda. So this is just an experiment with baking soda and vinegar. So what you do is you get the baking soda down in there, and then I have to stand back up here. Ruthie, will you please hold the bottle? And then you have to be very careful, but you put the balloon over the top of the bottle. Make sure you don't pop it. And then you kind of try to move the balloon, center the balloon over the top. And then dump it in and woo! So what's going on here is, hopefully not popping. What's going on here is actually a chemical reaction. We have the release of gas, but the gas wasn't there to begin with. I'm trying to pull it off here. The gas wasn't there to begin with. What the balloon is filled up with is carbon dioxide that was created when this reaction occurred. Now down in the bottle, we have a new substance formed. First of all, we have water is formed down in there, and we have carbon dioxide. Betty, ready? And we have sodium acetate. Sodium acetate.
Oh, that stinks.
It shouldn't stink anymore. It did smell like vinegar. See if it still does. Maybe just a little bit. Not bad though. It's not nearly as strong as it was before. Yeah. I'm going to see if it tastes like vinegar. You couldn't see, I dumped a little bit of it into here. I'm going to see if it tastes like vinegar. Ready? Not really. It tastes like a little bit of water. You can still taste the sodium bicarbonate in it, so it tastes just a tiny bit like soapy water, but not pleasant. But if I knew the proportions to get it completely done, I would have done that also. Okay, so our second experiment we have is with regular Coke. We've peeled the labels off so you can see it, and I've pre-opened it just so you can not have to watch me fight the Coke bottle. Are you snorting? So what we're going to do is we're going to dump 2 different things, and if you know me at all, you know I color code. So in this one we have, can't see it, nerds. In the blue balloon. In the yellow balloon, we have absolutely nothing because Ruthie's going to help me pour the Pop Rocks into the yellow balloon. You ready for Pop Rocks in there?
Yes.
And we're going to see which one causes a bigger reaction. And then we'll talk about what type of reaction occurred. Now remember, Ruthie, you have to pinch to make a spout.
Like this?
We have yes. I don't have any funnels at my house. I have these little silicone bowls. Pour it in. I have these little, whoa, too fast. Gotta let it get down in there, girl. I have these little silicone bowls that can be folded. Okay, finish dumping.
Okay.
She's got more in the box down here. I have these Coke things sitting in a box on top of Walmart bags to save my dining room table. Okay, we're good. Okay, so the first one we're gonna do is we're gonna dump some Pop Rocks down in here. and see what happens when we dump Pop Rocks in Coke, and then we'll talk about what happened. You ready?
Yes.
Are you excited?
Yes.
What do you think is going to happen?
I think it's gonna explode.
You think it's going to explode? Oh my
I
goodness.
think it's gonna
You
get
think
the
it's...
balloon too high and pop, and it's gonna.
Oh, you think it's going to make the balloon pop?
Yeah.
Okay, so, ready? Let's see what happens. Uh-oh, uh-oh. We do have some reaction going on. Oh, it's going up into the balloon. We've got stuff all in this balloon, and it's gross. And it's popping. I don't know if you can hear it. Hopefully this doesn't explode in my dining room. Ready? 1, 2, buckle my shoe. There we go. I released a little bit of, I poked a small hole in the balloon. There we go. Poked a hole in the balloon to make that reaction stop. Okay, you ready for, ooh, there's Coke all up in there too. You ready for the next reaction?
Yes.
Okay, we have Coke and
Nerds.
Nerds. We did get the rainbow Nerds only because it was easy to find. Pop Rocks were a little bit harder to find. We had to go to the Easter department and find them in Easter eggs.
Easter eggs.
That's always fun to get Mr. Moody to go searching for candy, isn't it?
Yes.
Okay, you ready? Hold the bottle still, handy dandy assistant. Okay, so let's see how Nerds do.
Yes. Nerds are gonna do great. Look, nerds are going in there.
We already have it dripping because there was a hole in the balloon that I didn't see.
It's going more than last time.
It is going more than last time. And the dog, I'm sorry again.
Yes.
The dog gets very excited over everything.
Yeah, his name's Griff, though.
Yeah.
He barks a lot.
He doesn't bark a lot. Ruby barks a lot.
And his dog name barks. She barks
Okay,
a lot.
so what happened here? Well, what really happened was not a chemical change at all. It was a physical change. So what's going on here? In order for the chemical change to occur, a new substance has to be formed.
Yes.
Carbon dioxide was created when we dumped sodium bicarbonate into the acetic acid. Here, we took Pop Rocks, which contain little bubbles of carbon dioxide, and we dumped it into something with carbon dioxide. So the carbon dioxide needs something to grab a hold of in order to bubble up. When it's just a regular Coke, the reason when you undo the top, it fizzes is because there's carbon dioxide under pressure inside the Coke. Oh. Well, the insides of the Coke can or bottle are smooth. And when it's smooth, it doesn't have any place, those little bubbles that are trying to form don't have any place to form. They need something to grab a hold of.
Yes.
Yes. Well, when you shake the bottle, what happens is the bubbles form, just like they do if you shake water. They form. But the bubbles when you shake Coke can bump into each other, and then when you release the pressure, kabooey. Well, the same thing happened here. The Pop Rocks, when the liquid dissolved the candy around the carbon dioxide sugar, or the carbon dioxide, sorry, not sugar, when it formed around the when it dissolved the sugar around the carbon dioxide, it caused the carbon dioxide to be able to it gave it something to hold on to.
This is
so
still
this
bubbling.
was a physical reaction. This is still bubbling.
No, this one is still
I know, this one is still bubbling. You can see it a little bit. Well, the reason the Nerds, I didn't put very many Nerds in there at all. I can probably dump a few more in there and it'll still bubble. The reason the Nerds work is because those bubbles, remember I said something about the smooth sides of the bottle? Well, the Nerds aren't smooth. Same thing happens with Mentos. Mentos aren't technically smooth. So it gives those little bubbles something to hold on to, and when they have something to hold on to, they have something that can help them move up to the top to explode. So these were actually physical reactions, even though there was a release of gas. They're physical because the gas was already there. it was not formed. So I hope you learned a little bit about, did you learn something about chemical and physical reactions? You're supposed to say yes.
Yes.
Okay, so hope you have a good day and have some fun with chemical and physical reactions at your house too. Say bye.
Bye.
Bye. Tell Chloe to say bye.
Bye-bye.
My finger's not letting me turn.